Hi everyone. Hope you went through the last session on problem solving using fundamental concepts about radiation heat transfer. Today we will try to solve few more problems on the same topic. This is the third problem we are trying to solve. The problem says a gray surface is maintained at a temperature of 900 degrees Celsius and maximum emissive power at that temperature is 1.4 into 10 power 10 watts per meter square. Calculate the emissivity of the body and the wavelength corresponding to the maximum intensity of radiation. So let us try to understand the problem. The problem says the given surface is a gray surface. It's not a black body, it is a gray body, right? So you have to be very careful in applying the formula. And its temperature is given as 900 degrees Celsius. Convert that into absolute temperature by adding 273. Then the maximum emissive power at the temperature is so much. That is monochromatic emissive power at a given wavelength is given as 1.4 into 10 power 10 watts per meter square. We have to calculate the emissivity of the gray surface. Because it is a gray surface, it will have finite emissivity less than 1. Right. Just to recall, the emissivity of a black body is equal to 1 as it is defined based on a black body. Right. So any real body will have, or any gray body will have an emissivity less than 1. That you have to calculate. Then lambda max you have to calculate. Right. Let us proceed. Okay. We know emissivity epsilon is defined as the ratio of emissive power of a given body to the emissive power of the black body at the same temperature. So we know the formula for finding the maximum monochromatic emissive power, EV lambda max is equal to C4 into T power 5. We know the value of C4, it is 1.307 in 10 power minus 5 and temperature is 1173 Kelvin. So from this you can find out maximum monochromatic emissive power of a black body at the temperature. The given body is a gray body. So the maximum monochromatic emissive power of the given body, that is given gray body, is given as 1.4 in 10 power 10 watts per meter square. That is known. Now using this formula we are finding the monochromatic emissive power of a black body at the same temperature of say 1173. Now let us take the ratio of these two values. We will get the value of emissivity. So emissivity is a maximum monochromatic emissive power of a real surface divided by maximum monochromatic emissive power of the black body at the same temperature we taken, and epsilon is found to be 0.482. Clear? Yes. Then second subdivision, to find out lambda max using Wien's displacement law we can find out. We already solved this in the previous problem. Simply lambda max into T is equal to 2898. You multiply it by 10 power minus 6 to convert that into meter Kelvin. Temperature is 1173 Kelvin. So lambda max comes to be 2.471 into 10 power minus 6 meters. Okay. Only two parameters need to be calculated. We calculated. Yes. I will move on to the next problem. Problem says a black body of 1200 centimeter square emits radiation at a temperature of 1000 Kelvin. Calculate the following: total rate of energy emission, intensity of normal radiation, and wavelength of maximum monochromatic emissive power. So let us try to understand the problem. So first thing in radiation heat transfer is to find out the type of the body or given surface, whether it is a black body or gray body. So this problem says the given body is a black body, so you are free to use all the formulae related to or applicable to black body, right? And area of the body is given as 1200 square centimeter. Convert that into meter square. So it is 0.12 meter square. Temperature of the body is given, black body is given as 1000 Kelvin, right? So what is the difference between emissive power or total emissive power and total rate of energy emission, right? So emissive power, as we already seen, is defined as the ratio, the amount of radiation emitted by a black body per unit time per unit area. Okay, right. So it is calculated per unit area, watts per meter square. Total rate of energy emission means the amount of radiation energy emitted by body in the entire surface area. That is, you multiply the emissive power by the surface area of the given body. That will give you total rate of energy emission. Unit will be watts. Clear? So emissive power is energy per unit area. Rate of energy emission is simply energy, not per unit area. Right? Yes. So our first job will be to find emissive power. So as per Stephen Boltzmann law, emissive power is sigma into T power 4. Right. Now we are multiplying it by the area of the body to get total energy emission. Right. So area is 0.12 meter square. Sigma, temperature is given as 1000 Kelvin. So we'll get energy, total energy emitted is 6804 watts. Understood? Okay. Then to find the intensity of normal radiation, so this formula is known to you. Intensity of normal radiation I suffix n is equal to emissive power divided by pi. Emissive power is nothing but sigma n T power 4. So if you calculate sigma n T power 4, you will get 56700 watts per meter square. You are dividing it by pi. So you will get intensity of normal radiation as 18048.17 watts per meter square. Clear? Then third subdivision, to find the maximum monochromatic wavelength corresponding to maximum monochromatic emissive power. Nothing but lambda max. We already seen many times, so I am skipping this.